All right, so example 3, we've got an experiment where somebody is recording data about the number of cars waiting in line at a, does it say what it is? Waiting in line on a Friday at the drive-in teller at the Westwood Savings Bank. Okay, so they've got someone who's out there and they've been told to write the number of cars that are waiting in line at 2-minute intervals. Okay, so they're gonna write how many cars are in line. They're gonna wait a full 2 minutes. They're gonna look up and write the number. The write the number of cars they see at the next 2-minute interval. Okay, and then again wait 2 minutes. Again, record the number of cars. Wait 2 minutes. Record the number of cars. Okay, so that's the experiment that is happening here. And then we're given a bunch of data. Okay, now this data has been processed. I mean, if you looked at this person's sheet or clipboard that they were recording the data on, you would probably see the time intervals, and then they would be recording 1 or 2 or 3 or 0 or 6, or then 1 and then 2 and then 8 and then maybe 6 and 0 and 1, and you're going to see a bunch of different time intervals, and you have the number of cars recorded at each time interval. Okay, so you're going to have a list of values, and then somebody has taken the data and put it together, put all of the intervals that, they counted the number of intervals where they observed 0 cars in line, and there were apparently 2 time intervals where that happened. 2 time intervals, they recorded 0 cars. Okay, for 9 of the time intervals, they recorded 1 car in line. For 16 of the time intervals, they recorded 2 cars in line. So that's the first thing that's important, is to understand what are they showing you here. So if you add up all of these occurrences, you get 60, which means that they recorded data for 60 time intervals. So this is 60 intervals or 60 trials where they looked up and recorded some data. So intervals. So there were 60 intervals, right? So they recorded data, then they didn't do anything for 2 minutes. At the end of 2 minutes, they recorded the data again. Okay, so the data that they would have written down would look very different from what's here. All right. So what's here is someone had gone through all the data and counted how many time intervals there were for cars in line. And when they counted the number of times this person wrote down 4 cars in line, there were 8 of those time intervals that had 4 cars in line. Okay, so it's important to know that there were 60 time intervals. So it's basically 60 trials of recording data, and then they've just aggregated it in a table. All right, so part A then is asking, find the probability distribution of the random variable x, where x denotes the number of cars observed waiting in line. Okay, so if x is the number of cars waiting in line, the numbers that they recorded were either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, right? So let me see. 8. So they never recorded any more than 8 cars in line. All right, and there were 60 time intervals, okay, total, where they recorded some data, one of these numbers, all right, for 60 time intervals. And so in order to calculate the probability, we're assuming this is a representative sample for that particular time period, we know that 2 out of the 60 time intervals that they recorded data for, 2 of those time intervals had 0 cars. They recorded 0 cars waiting in line. Okay, so essentially you could just write 2 out of 60. So I don't know if you want to write that as a decimal. I didn't write mine in my notes as a decimal. I just wrote it 2 out of 60. It's easier actually, and this, I know it's reducible. We could reduce it to 1 out of 30, but I'm just gonna leave it as 2 out of 60. Okay, because I know what's coming, and it's much nicer to add probabilities if they have a common denominator, right? We can't add fractions unless they have a common denominator. So I'm just gonna leave it as 2 out of 60. All right. So how many times did they record 1 car waiting in line? Well, so here's one car waiting in line, and apparently 9 different intervals, they recorded 9. So 9 out of 60 intervals, they recorded one car waiting in line. All right. How many times did they record 2 cars waiting in line? Well, here's the 2 cars waiting in line. 16 out of the 60 intervals had 2 cars waiting in line. All right, so we could consider the probability, if this is a representative sample, that it would be 16 out of 60. Okay, how many times did they record 3 cars waiting in line? Well, 12, right? So it's 12. 12 of the time intervals out of 60, they recorded 3 cars waiting in line, and so on. So we're just going to take the frequency of occurrence out of the total number of intervals that were recorded, right? So when they recorded 4 cars waiting in line 8 times, so 8 out of 60 is the probability for 4 cars waiting in line. 5 cars waiting in line, they recorded 6 out of 60 intervals. They had 5 cars waiting in line. They had 4 out of 60 of those intervals had 6 cars waiting in line. 2 out of 60 intervals had 7 cars waiting in line. And then 1 out of 60 time intervals, they recorded 8 cars waiting in line. Okay, so we can use these as our probabilities if this is a representative sample. So so then part B is asking, what is the probability that the number of cars observed waiting in line in any 2-minute interval between 3 and 5 p.m., right? Because that's for we were recording between 3 and 5 p.m. All right. So is less than or equal to 3. So what's the probability that our random variable, we can write this as the probability that x is less than or equal to 3, okay? We're just going to add up the probabilities, okay? Because all of these are mutually exclusive, so we can just add the probabilities. You know, we can't have 2 cars and 3 cars waiting in line at the same time. It's either going to be 2 or 3. All right, so we're just going to add up the probabilities. So we have 12 out of 60. We have 16 out of 60. And then we have 9 out of 60. And then we have 2 out of 60 times we had 0. Okay, so less than it, we're just going to take all of the probabilities. Oops. We're going to turn around a bracket, right? All of the probabilities where x is less than or equal to 3. Okay, add that up, and I got 39 out of 60. Now I can reduce it if I want to 13 out of 20, or I could write it as a decimal. Okay. All right, so what's the probability that we have between 2 and 4 cars waiting in line? So I can write this as 2, that the random variable is between 2 and 4. Inclusive, so I'm going to include less than or equal to. All right, so I'm just going to take those values between 2 and 4. So let me actually, I'll just write it this way. 2 and 4, so we're going to add up those probabilities. So I've got 16 out of 60 plus 12 out of 60 plus, what, 8 out of 60? 60. So add those up and I get 36 out of 60, and I can reduce that to 3/5. So 60% chance, right? 3/5. I'll just write it as 3/5. All right, so let's use a different color for this one. What's the probability that we had greater than 6 cars waiting in line? So probability that the random variable is greater than 6. Okay, so it says greater than, not greater than or equal to, so I'm not going to include 6. I'm just going to add up these two. 7 and 8 are the only ones greater than 6. So I'm just going to add 2 out of 60 plus 1 out of 60, which is 3 out of 60, which is 1 out of 20. Okay. So that's all there is to it. Just using probability distributions, sort of like the way we, pretty much like the way we were using them in chapter 7, and only now we've got a random variable involved. All right, so I'll meet you in the next video.